I'm Pete Barnett from InfluxData, and I want to start this session building on with a little bit of a quick pulse check, all right? And I mean that literally. If everyone could just check your pulse for a second here. See a few people doing it. Congratulations. You just sampled time series data. It's exactly the type of data that we try to focus on here at InfluxData. It's a great opportunity to talk through a lot of the use cases, how you can actually leverage this type of time series data for not just better health insights, but better telemetry data, industrial, IoT, geospatial data, and so much more. So InfluxData, a little bit about who we are. We're the creators of InfluxDB, which is the widest, most active used time series database, over 1 million active instances. We're also the creators of Telegraph, which is even more well used across many different types of databases for ingesting and transmitting data into a lot of different types of areas as well. And then we're the category leader in time series databases. We'll talk a little bit more about what exactly that is and why time series data is so important for what we're actually doing today in this conversation. And just a little bit more, so InfluxDB over the years, right? Back in 2016, even further back than that, starting at Y Combinator, we released 1.0, which was really about metrics at scale. How do you actually take and ingest a ton of different data? We're talking millions of data points, and how do you actually keep all of that actively being processed, transformed, and understood? And then we released 2.0 in 2020, which was the platform in the cloud with an expressive processing language. It allowed you to actually translate, understand, aggregate, and do so much more with the data that you have, and getting better insights from that data. And then with 3.0, which we only recently released, a real-time columnar database. And when we say real-time, we're talking sub-second, even less than 100 milliseconds, even lower, to ensure that you're getting the fastest response rates on your analytics, on ensuring that your queries are rapidly responding, and that you can take action as soon as anything is possibly going wrong or as events are actually occurring. So what is time series data? So we all sampled our pulse right there. That's great. That is time series data. But specifically, it's data with the purpose of knowing what happened or what is currently happening at specific points in time. And this comes in a lot of times sensor data. You can think anything in IoT. You can think a lot of different areas around digital world instrumentation. But you can also see it's so many different areas where time series data just shows up in either what's on your wrist, on your watch, or what you're actually doing in terms of the cars that you're driving and how you're actually leveraging GPS, and so much more actually driving what that time series data is. And that comes in two types of data. You've got metrics, and then you've got events. Now metrics is oftentimes what, for example, going back to health, right, your pulse, consistently coming in at a very standard rate. But if you have something perhaps like atrial fibrillation, well, that's going to be a sudden change in what that standard pulse rate would be. And that's going to be an event, something that you can capture and recognize as being a little bit outside what the standard process is. You can think this is very common with server data, where maybe you're actually seeing a spike in your CPU usage, or maybe you have a very large sort of a server actually go down, and that's going to register as an event as well. And being able to take that data and respond in milliseconds to being able to take proactive measures to ensure that you can actually keep that server healthy, that you can kill processes that are going to ultimately take it down, being very proactive at the edge, so ensuring you never have downtime that you're not prepared for. And why does that matter long term? It's because it's going to provide you with clarity of not only the past and the present, but how you can put yourself in a position to better predict the future. Financial analysis is a huge one. You can think of this, doing anything with stocks, and financial trading is a big case, anything in the health-related sector. Temperature and weather conditions, being able to monitor weather patterns, continue to be these types of data points that enable you to make proactive decision-making based upon the models and the data that you've actually aggregated and been able to create these new interesting insights over time. And so let's talk specifically about why 3.0, the newest version, is so interesting and what it brings uniquely, specifically on the real-time side, to being proactive, right? So as I said, hot data, having that sub-second response rate for your type of inquiries is what's going to enable you to take that faster decision-making process going forward. Storage costs are so much lower on 3.0, leveraging Apache Parquet and its great sort of object storage approach. And then unlimited cardinality, so you're no longer restricted at scale. And that's one thing we've seen across so many different databases when it comes to trying to do analytical queries, is that you just ultimately get stopped at scale when you're trying to really express across a lot of different instruments, a lot of different sensors and data points. And with 3.0, that's no longer an issue, which is really exciting. So how do you actually get closer to real time, right? A little bit more on the technical side. What does it actually mean? Well, when we're trying to solve analytical problems here, that's called OLAP, online analytical processing, right? And that's different than OLTP, which is online transactional processing, what you generally speaking use an RDBMS for. And specifically when it comes to analytical processing, you care a lot more about all the data in what you could think of as a single column, rather than all the data that you would see across a specific row. That's the simplest way to sort of explain that kind of concept. And so in getting closer to that real-time space, we've got an example here of what you may see for some server metric data. You've got IDs, times, CPUs, etc. And if you actually want to be able to run analytical processes on your CPU, you want to know what's my average CPU usage, what would define something being a little bit of a spike, or maybe something you need to actually take a piece of action on. Well, you don't want to have to constantly process all of your memory, all of your network activity as well when you try to find that information. Instead, if you want to respond rapidly, you're going to have to ensure that you're only querying the data that you distinctly need in that scenario. And so in this sort of walkthrough here, we don't even have to query what the ID, the memory is, or the network activity is. If you're trying to understand what your processing is for your CPU, you only have to query those specific columns, and that gives you just much more rapid response rates because you're no longer having to process specific columns and then throw out that data because it's not actually relevant to the work that you're trying to understand. And so how do you sort of solve that also architecturally? Well, one of the problems with real-time is that anywhere along the pathway that you have to extend into a different space or you have to sort of extend out your architecture, you are adding latency. You're adding just ultimately different pathways that your data has to go through, which is going to slow you down. And that can be fine if you are all right with things taking several seconds or longer. But when you need to get sub-second or sub-100 milliseconds, every single path along that is just time you don't have. And so ingestion pathways have always been bottlenecks. And this is a very simplified but realistic ingestion model where you go through an ingester that perhaps does any data cleanup, any sort of appendages, transformations, puts that into storage, and then your querier, where you're actually sending your queries to, goes back to that same storage and retrieves that information. Works great for lots of different scenarios, but it's not great for real-time analysis. And so with InfluxDB 3.0, what we've leveraged is actually querying directly from ingest. And so before you actually have data that's even had to go and be persisted all the way into the storage provider, we're able to actually query that data as soon as it's ingested. So within milliseconds, you can better understand what do you need to do in terms of taking any actions. Does this specific data cause problems? And are you able to actually proactively prepare for what's going to come next in your data pipeline? So that data will still be persisted to that long-term storage, but you're just getting that access to that data so much faster because you don't have to wait for it to be persisted, modified, transformed, and turned into a specific data file format. You can ensure you're getting access to it a lot faster in that pathway. And so how can you leverage InfluxDB? And it's been great talking to so many people, hearing the ways they've been doing it. Several people have been using it for years and years. A lot of home automation scenarios are great for those types of experiments. We're open source. We were founded as an open source company. We've had open source for all of our different products as well, and it's been exciting sort of moving in that direction. We continue to have a very vibrant community that helps build in a lot of that different space. And our team as well is very committed to driving into that open source area ever forward. And then for those smaller workloads, we have multiple different ways you can actually engage with that. But one of the ones we've really found is that cloud serverless, which you can just sign up online, get free access, and being able to understand, hey, how can I just get started with InfluxDB? How can I get started with just time series data? It can still be a pretty nebulous topic, and trying to actually drive into that space can sometimes be hard to understand. And so cloud serverless really lowers that barrier to entry. Easy to get started. If you're familiar with Telegraph, we just automatically create those plugins for you, so you don't have to worry about actually setting up any of that data set. You can get started in about a minute or 2 minutes actually monitoring your own system and understanding what its performance is and setting up any sort of regulations from that. One of the more exciting ones as well is TimeStream for InfluxDB. It's a new sort of a first-party system, part of AWS TimeStream. TimeStream, if you haven't heard, is now actually an umbrella term for two products. One is TimeStream for live analytics, and the other is TimeStream for InfluxDB. And so if you actually want to use InfluxDB on AWS, There's a native managed platform called TimeStream for InfluxDB. You can get started, again, in just minutes, and it's a wonderful platform. We're really excited about the progress we've seen there. And then, of course, again, going back to scale. As you scale, when you have these large organizations that have thousands of sensors and you're constantly streaming data in, and traditional database models would just crumble under this type of load. With Cloud Dedicated and Clustered, we're able to leverage 3.0's new performant architecture to not only handle that load and keep real-time data and keep that real-time analysis, but keeping storage costs low. A lot of times what you see is if you start trying to ingest a ton of data all the time, every second for days and days, your storage costs spike dramatically. And so leveraging our new Apache Parquet format, ensuring that we actually have object storage, you can reduce costs dramatically. It's great for scaled workloads. And so, talking a bit more about these open source, again, there's actually a QR code. I know a lot of people have been asking, hey, where's 3.0's open source? I'm really excited to say it's coming very, very early in Q1. We're really happy for having worked through this. It's been a real awesome product to have been a part of. There's a QR code you can scan to be notified. It's also at booth 1080. You can make sure to sign up there. It's coming very, very early in Q1. Again, super excited. And you can get started locally in less than a minute. You can just quick install, boot it up, and be able to monitor your own system, or if you want to monitor your own home automations, maybe you have outside weather temperatures, you have fish tanks, anything really of that type where you need to understand that time series data. InfluxDB open source is going to be an awesome way to sort of get started there. And then cloud serverless, again, like I said, with built-in visualizations, which is key. Now, if you want to leverage and use something like Grafana, which is another awesome sort of solution we've really worked with and have a great partnership in dealing with, able to build in very cleanly with those. One of the great things about cloud serverless, though, is those visualizations already come pre-built in, so you can track that data, better understand how your specific server is doing, how any weather data is coming in. You can easily pull in data from external APIs and just sort of update and leverage that data to help enrich the type of information you're trying to store, analyze, and process as a whole. Now, as I said, Amazon TimeStream for InfluxDB, you can actually find this just on the AWS console. It's not even a marketplace. You can go to the console and discover Amazon TimeStream. It's a lot of different information to get started. One of the best things we've really been working hard on is ensuring you have not just great performance, but also that high availability. And there's even more coming there soon. So we're really excited about a lot of the different options. And it's a managed cloud solution. So you don't have to worry about how do you actually set this up, maintain it, how do you sort of observe the observers. All of that is sort of obfuscated away. So simple to get started with as well. Really have loved the opportunity to work with the Amazon team in doing that. And then some of the bigger ones, right? So we talked about Cloud Dedicated, but Cloud Dedicated is when you have that massive scale, when you have infrastructure that you just don't want to handle, because at that type of scale, time series databases, maybe that's not just where your forte is, understanding how to build, monitor, leverage, and grow that sort of infrastructure. Well, Influx, we've been doing it for a while, and so we've come to know that sort of solution very well, how to best tune it for your needs, getting the best performance possible, and that's why we have Cloud Dedicated, where we'll take that sort of solution, put it in the cloud for you, give you access, but we'll make sure it stays up consistently. And then again, when you have that high ingest, that high scale, when you consistently are trying to pull a lot of data in from different sensors or different notions, perhaps you're dealing with different car sets that you're setting through, or just sensors in the wild, this can all be handled through a cloud dedicated platform. And then finally, clustered, which is, again, some people want to take this and put it in your own private cloud, or maybe you have your own on-prem infrastructure you want to build it on. And we can sort of very easily leverage this large-scale time series solution, put it into that scenario. We'll actually build it on top of Kubernetes so that you have a much more sort of seamless managed approach within your own cloud environment or your on-premises environment as well. And it's a great opportunity to, again, have that in the private cloud or on-premises while still getting that robust edge of data, really high, fast time to analysis on InfluxDB cluster. And so, some scaled of those use cases, right? If you're looking at like that expansive monitoring, DevOps monitoring is a big case we oftentimes see. When you're trying to actually monitor, your networks, your systems, understanding more clearly what's going on throughout those different pipelines, huge area that we see. Scaled and analytics, right? Real time for IoT. Internet of Things continues to grow, and the types of use cases we've seen around predictive analytics, leveraging all of that type of information, sending it to an area where maybe you can scale and learn more, train models on that type of data. We see a huge influx of that type of use case over time, especially over the past couple years. We even see it sometimes on smaller at-home approaches as well to see how they can sort of train their own smaller models on that type of analysis. And then high cardinality, anything dealing with huge scale in terms of lots of different types of data. Custom analytics applications is where we see a lot of this request. And this comes, really with tracing and being able to actually understand your analytics platform as a whole. This is where we're going to see cardinality expand dramatically. You're going to have a lot of different data. You're going to have a lot of different use cases. And if you're trying to query that data on a different type of database system, the lag and the load is going to excel not only into the tens of seconds, but into the tens of minutes eventually. And that's why we're able to ensure that we're keeping that dramatically fast and that you're getting high quality results every single time. So if you want to learn more, InfluxData.com, that's our website, that's who we are. Again, of course, we're also at booth 1080. We're here all week. I'll also be over here and back at booth 1080, so you can come stop by. We still have some socks available, so highly hope those are all gone before we head out for the week here. But that's the quick oversight of it, all right? Again, when we're dealing with time series data, ensuring that we have high quality results all the way through, that you're always having that real-time analysis so that you're not waiting on data to process, and then by the time you actually understand what's happened, the server's already been taken down. We're able to actually make a more proactive approach to solving those problems at InfluxData, leveraging InfluxDB. That's what I have. I'm happy to answer any questions if there are any.